Hey guys, in this video we'll be looking at a concept called pointers in C programming. What is a pointer? A pointer is a variable which stores the address of another variable. This variable can be of type int, char, array, function, or any other pointer. Now what this is telling us is that we will have a variable that only addresses is its value instead of numbers, letters, sequence of characters. This variable stores only addresses. What are the benefits of using this pointer? This pointer reduces the code and improves the performance of our code. We can return multiple values from a function using the pointer. And also it makes us able to access many memory locations. Let us jump into the actual coding. Remember what I said about a pointer, that a pointer stores another variable address. Whose variable are we going to declare right now? We are going to declare a variable of x that has a value of 10. This x variable is what a pointer stores its address. Okay, so we have declared a variable. Let's declare a pointer. We declare a pointer by specifying the type, then with this asterisk. This asterisk means indirection operator. This asterisk means indirection operator. Okay, now having that in mind, we now name our pointer variable with p. So this is the pointer variable, and this is the variable that we want to get its address and store inside of this our pointer. So we having these two things here, the next is to assign our pointer an address. So we come down here, write p equal to ampersand sign and x. Now to get an address of a variable x, we use this sign called ampersand. What ampersand means is that it goes and gets the address, only the address of x, our variable x. Okay, so right now we are getting the value or the address of x in memory and passing it to our pointer. So right now our pointer has the address of this x in memory. What we are going to do right now is that we are going to print this address to the screen. Address of x. Okay, we are going to print it to the screen so that we will see it. So you can see the address of x, 6422036. That is the address of this our variable x. So right now we have assigned the address of x to our pointer p. We can actually using this address, we can actually print the value of this x. So for us to do that, the only thing we need to do is just to put this indirection operator in front of p. Instead of address here, we put value. Value of x is, so value of x here is 10. So you can see the value of x here is also 10. So what is this saying to us? Remember that when we declare this x, we reserved a space in memory that we hold a data type of integer and a value of 10. Now, inside the memory, a space of an address was reserved for us. Now, for us to actually know the actual address of this variable x, we employed this ampersand sign. Now, you may be asking, then what is the work of this x here? Now, the work of this x is that it allows us to remember the where we stored this value 10. Because if we are trying to use the address of this x in memory, we may not be able to get or remember it, but rather we used x to represent it in our program. As we have seen here right now, through the address of x, we were able to print out the value of x. So that also tells us that the address also has this value, not only this x here. The x has the value quite alright for us to use for a more readable name for our program. We use x, but the computer actually knows what this x represents. Okay, so it uses the addresses in memory to work with, while the programmer uses this x here to work with. Okay, having that explanation simplified, let's move on. Now that we have actually gotten the address and we printed the address and the values, next is for us to try some other things. For example, we are adding 2 here. Let's print out 2. Now the value of x is 12. Okay, now what if you have another variable called y and you gave it the value of 100, and you want to know the address of this y, what this y is actually representing in memory? Now what we need to do is we need to assign, okay, let's just use that same pointer, which is this p. Okay, we just need to change this x to y. Okay, and having this in front of y, it's actually carried this address of y and gave it to this pointer p. Now if we print right now, we'll be printing the address of p instead of the value. We'll be printing the address of p. Now you can see that the address of p is still the same thing as the address of x. Or let us confirm this. Instead of us to use the same pointers, let us try to use a different pointer. Now for the p, I will use q for the address, but for the x, I will use p for it. So this one is for the x, which is for p, and this one is for the y, which is for q. Now I will print 2 different values here. Address of y is p, is q, I mean to say. So let me do a new line. Okay, so you can see that the address of x is 64222028 and the address of y is 64222024. You can see they have two different addresses, okay, because they have two different variables. Now, for us to, have you ever wondered, let us do some manipulation, just a slight manipulation. I want this address of y to be the same thing with the address of x. So here inside this y, I want it to be 64222028. Instead of 4 here, it will change to 8. Now for us to do that, what we are going to do is we'll just put +1 in it. Let's run. Now you can see that the address of x is 64222028 and the address of y has changed from 64222024 to 64222028. Y is now has the same address of x. Now what you did here was that you moved to the next address. Okay, you are in the address of y, but you moved a step further ahead. Okay, so address of x is in front of address of y. So that is why if we put 1, we move to the next address. If we put 2, we move to the next address. Okay, but that doesn't mean that the values changed. The values did not change. Let us check the values. Now value of x is and address of x is. So let us also do this. Then we now put this asterisk p, comma, then here indirection operator q. So let me remove this and run. So the value of x is 12, which is what is here. 10 plus 2 is 12. Now the address is 64222028. The address of y, this one's supposed to be y. The value of y is 100 and the address of y is this. Okay, now let us now move this address of y to the next address in front of it. Let's see what is going to happen. +1. Now you can see that the value of y is still 100, but the address of y has changed to 64222024, which is the same thing as the address of x, 64222028. That is a way to manipulate addresses. You can actually assign this x address to this y pointer, and the y pointer will now have the address of x. Okay, but that is not the aim of this video. We don't need to manipulate too much. We just need a simple understanding of a pointer. So let's remove this +1 here. So you can see how we defined two variables, declared the pointers of these two variables. The p has the address of x and the q has the address of y. Now we initialize the pointers to have the address using this ampersand sign. This ampersand sign is for getting an address of a variable. Okay, so we assign it to these pointers here. Now we printed the address and the value of x. For you to print the value of x, you must provide this indirection operator, which is this asterisk, then the p. But if you want to only print the address, you just provide the p. The same thing with the value of y. If you want to print the value of the pointer, you put the indirection operator. But if you want to only print the address, you put this q, which is the pointer, and it will print for you. Okay, so this is the values of x and y, and this is the address of x, and this is the address of y. So guys, this is how to initialize variables, assign variables address to a pointer, and then printing it out. So in the next video, we'll be going through another pointer, but we'll be using an array for it. Okay, right now we are not using pointer with an array. No, we are just using an ordinary variable with a pointer. So stay tuned.